Let's consider addition and subtraction of fractions. To add fractions requires having a common denominator. Then we simply add the numerators and keep the common denominator. So the sum of A over C and B over C is the quantity A plus B over the common denominator C. For example, the sum of 2/3 and 5/3 is 2 plus 5 over 3, or 7/3 simplified. Similarly, the sum of x over 3 and 5 over 3 is x plus 5 over 3. Since x and 5 are unlike terms, this is as simplified as possible. Likewise, 2 over x plus 13 over x is 2 plus 13 over the common denominator of x. This simplifies to 15 over x. Subtraction of fractions also requires a common denominator. To compute A over C minus B over C, we subtract the numerators, A minus B, and keep the common denominator C. Again, considering examples, we see that 5 over 2 minus 3 over 2 is 5 minus 3 over a common denominator of 2, or 2 over 2, which simplifies to 1. X over 3 minus 8 over 3 is x minus 8 over the common denominator of 3. This is simplified as much as possible with unlike terms in the numerator. Finally, 9 over x minus 5 over x is 9 minus 5 over x, which simplifies to 4 over x. When attempting to add or subtract fractions with unlike denominators, we must first get common denominators by multiplying by a clever 1, then adding or subtracting as before. For example, when adding 7 over 8 and 5 over 12, we notice that we don't have common denominators. The least common multiple of 8 and 12 is 24, so 24 would be the least common denominator. We want to use the least common denominator in order to minimize the amount of simplification that must be done after the numerators are combined. So we rewrite 7/8 as 7/8 times 3 over 3, and rewrite 5 over 12 as 5 over 12 times 2 over 2. Notice that multiplication of any number by 1 maintains equality. The multiplication, which has priority over the addition, produces 21 over 24 plus 10 over 24. Now we have common denominators, so we can add the numerators and get 31 over the common denominator of 24. Fortunately, no additional simplification is necessary. Now let's consider 9 over 8 minus 4 over 5. The least common multiple of 8 and 5 is 40. So multiplying 9/8 by 5 over 5 and 4/5 by 8 over 8 maintains equality. We get 45 over 40 minus 32 over 40 when we compute the multiplication. Subtracting numerators gives us 13 over 40, which again requires no additional simplification. Let's add 3 over 10 and 8 over 15. The least common multiple of 10 and 15 is 30, So to get a common denominator of 30, we're going to multiply 3/10 by 3 over 3 and 8/15 by 2 over 2. Performing the fraction multiplication, we get 9 over 30 plus 16 over 30. Adding the two numerators, we have 25 over 30, which does simplify to 5/6. To review the fraction simplification property, you can refer to the video on fraction properties. Now consider 8 over 9 minus 4 over 15. The least common multiple of 9 and 15 is 45, so that will be our common denominator. We will multiply again by a clever 1, multiplying 8/9 times 5 over 5 and 4/15 by 3 over 3. This produces 40 over 45 minus 12 over 45. Note that it would be a mistake at this point to reduce these fractions, since we need the common denominator to subtract. Subtracting with the common denominator produces 28 over 45, which is simplified. Finally, let's consider 8 over 3x minus 5 over 6. This time we need the least common multiple of 3x and 6. This least common multiple is 6x. So we're going to multiply 8 over 3x by 2 over 2 and multiply 5 over 6 by x over x. Incidentally, we know that x is non-zero because 3x is a denominator of our original problem, and denominators are required to be non-zero. Now multiplication produces 16 over 6x minus 5x over 6x. Subtracting with the common denominator gives the quantity 16 minus 5x all over 6x, and this expression is simplified.